Okay, since this is the end of week 3, I figure you know what's going on already this week, especially since you've been watching these or coming to these, Zooms. So, I'm gonna move on to next week's lab, which, is the Island Biogeography lab. So I'm gonna talk about basically like the pre-lab talk you would get in the classroom that day, and I think it's a little less formal than what's on the video. So if you get confused about something, just stop me and ask any questions. So what I'm gonna do, I'm gonna share my screen, but this time I'm gonna start with a whiteboard. And I've not done this with you guys yet, so let's hope this works. So I'm just flipping my laptop over and probably need to shrink that down. Okay. So, what we're going to be doing is we're going to be testing the theory of island biogeography. The theory of island biogeography was proposed in 1967 by two people, one of whom you already know from your readings, and you already know MacArthur because you've already read in the first chapter of your book about MacArthur and his warblers. And so we're going to talk about MacArthur, but we also have a collaborator, E.O. Wilson. And when you get to the chapter where they talk about this, I'll talk more about Wilson and who he was. But they were really interested in patterns of species diversity, where you would find the most species. And they based what they were doing on some work that had been published a few years, only a couple of years before them, by somebody named Preston, that was really looking at the relationship between area and species. So I'm going to draw a little graph here. And so I just wanted to remind people when you're dealing with graphs, this axis here is your x-axis. This is your y-axis. And your x-axis is your independent variable. And your y-axis is your variable that is dependent on it. So the x-axis is the one, it's gonna go up and down. It doesn't care about what's happening on the y, but the y, whatever this is on the y-axis, cares very much about what's happening over here on the x-axis. So in this case, our x-axis is going to be the size of an area. So it's going to be the area, and that could be, it could be square kilometers or square meters. In our case, with this lab, it's going to be square centimeters. And this is a fairly intuitive relationship between the number of species and the area. So on the y-axis, we have the number of species, which is also called species richness. So species richness, if I use that term, it's exactly the same as just saying the number of species. And the relationship, as you would expect, it's going to be a positive relationship. So it's going to go up from as you increase your area from small areas to large areas. You're going to go from small numbers of species to large number of species. And the relationship ends up, it goes up and up and up and up and up. And then you start to run out of species in the region. And then it's hard to find, you might make it bigger and bigger, but once you get to the size of North America, there's just whatever number of species there are in North America. So you have a relationship like this. So MacArthur and Wilson took this one step further, and they came up with a mechanism to explain this, why this happens. And they decided the easiest way to illustrate it is to look at different sized areas. And so you could look at small areas and you could look at large areas. And they figure, well, islands do that. Islands have there's small islands and large islands. And so when they described their theory to explain this, they called it the theory of island biogeography, even though it ended up extending to more than just islands. So I'm going to go ahead and clear this. And I guess I'll draw an island. This is kind of fun, actually. So I've got a little island out here, and I should have an ocean. So I've got an ocean along here. And then over on the right side, instead of an island, I'm going to draw a mainland. So this will be a mainland area. So this is like a continent or something like that. I don't got a mainland here. And we have an island here. And on my mainland, I'm going to put some species, and I will do them in another color. So we've got like big birds, like my drawing, little birds, little round birds, tiny birds, um, X birds, and then we could have several of each species. So these are different species. So we have all these, we have what's called a species pool over here. It's just lots of different species. And eventually big birds will start flying over the water, and some of the big birds will end up on the island. And maybe, my little birds will start flying over the water and they'll end up on the island. And so if we just look at this one island, I'm going to make another graph because we ruin everything in science. So we just turn it into graphs from cute little birds flying over to islands. And so on this graph, instead of, remember I had area on the first one I showed you. On this one, we're just going to say how many species are on the island. So the independent variable, so the x-axis, which is independent, is the number of species already on the island. And then my y-axis is how many new species will come. So that's going to be, this process of moving from the mainland to the island is immigration. So the y-axis is going to be the rate of immigration. And that rate is going to be the number of species per time period. So it could be the number of species per year, or it could be per decade, or it could be, you might be looking at something with insects. It might be the number of species per week that come onto the island, depending on what species you're looking at and how far the island is and how often you visit it. So just like the little hashtag is number, SPP, when you write SPP, that equals multiple species. And if I just write SP, that's just one species. And if I ever write something you don't know what I'm writing, just tell me, because it's not as nice and neat and clear as doing it in a PowerPoint. So if I've got no species on my island, then everything that comes there is a new species, or most things that come there will be a new species. So for an island that doesn't have any species, you get high immigration rates. But then as it starts to fill up with species, so as we start to get, the little guys and the X's and the O's and all of them there, it's hard to have new things come there. So you end up with a relationship that is actually going from having lots of species to having very few species. So this is the immigration rate. And if you're on your island and you're the only species wandering around, that's great. No one's going to eat you. No one's going to compete with you. But if there's lots of other species there, so we're going from, it's getting a little messy here, but we're going from a low number of species to high number of species here. If there's lots of species there, then you're going to start competing with each other. And some of them will get eaten, some of them will get eliminated. So some of these little guys down here on my island will get outcompeted. Oh, my island just got outcompeted. They'll be outcompeted or they'll be eliminated. And so you'll have very high rates of what's called local extinction. The species will disappear from the island. So if we've got lots of species there's going to be lots of extinction events. If we have few species, there's very few extinction events. So you just end up with some sort of positive relationship there. As you get more species, so remember, this is your number of species on the island, you're showing that the local extinction rate goes up as you have more species. Now, these two lines conveniently cross, and where they cross, that is actually a point at which immigration of new species, the immigration rate equals the extinction rate. So for everyone that's going extinct, there's that number coming back onto the island from the mainland. And it might not be the same species that's going extinct, but the number of species stays the same. So this is an equilibrium. And if we just read down, we can see at what number of species you'll achieve this equilibrium on this particular island. And we're just talking about one island here. So we have one island and we can see what is the equilibrium number of species where immigration and extinction will balance each other out. So this was the basis of their theory of island biogeography. They wrote this book, and first they published it in Ecology in the Journal, and then they made it into a book, which they published with Princeton University Press. And then in that book, it talks it talks about these generalities, but it also talks about the shapes of these lines and the mathematics. But it's like it's like those pick your own adventure books where you get to a point and it's going to go into the math, and they say if you want to skip the math, go to page 53, and then you can skip all the math and it reads just perfectly without all the math in it. So it's a very readable book. So everybody read it. It's a very popular ecology book. So the other thing that they talked about though is if your islands are bigger, then they're a bigger target. So if my island, let's say I have another island here, I will make it a blue island. And if my island was much bigger, then it's easier to get there. So my immigration rate is probably going to be higher. And there's more space to hide, more resources. So my extinction rate is supposed probably lower. So this is my extinction rate from my big island and my immigration rate from my big island. And they're going to have a much higher equilibrium number of species. And that's what you're going to be simulating and testing with this lab is you're going to be doing immigration and extinction, but instead of real species, we're simulating that with the craft sticks that are in your kit. So when you're going to do this lab, you're going to set up 3 sizes of areas, and you get to pick what 3 sizes you want. So you can have do a big area, a small area, medium-sized area. And you're just going to do one island of each size. And then we're going to be able to pool the class data so that you will be able to get more areas and more replication, more other people's tests of the different areas. From doing this last fall, I'd advise you not to do the 1 meter by 1 meter area, the biggest one. It's a lot of counting of a lot of sticks on that. So I would steer away from that. And then when you set this up, this is the one lab you can do inside because with the snow and everything and the cold, you don't have to go out and use your little stakes and your twine like I show in the video. You can just put some painter's tape on the floor and mark out a spot on the floor. And if you're going to do it inside, what I recommend you doing is do it with a wall on the other side behind you so that as you're throwing sticks, you don't have to be like running down the hall trying to find your sticks. And then also mark with your painter's tape or something on the floor a spot that's going to be 2 meters away from your edge of your island. So you're just going to measure that out. And this distance is going to be 2 meters, 2 meters, 2 meters. You can just put a little X on the floor at that spot there. And so where you've marked your little 2 meters, that's where you're gonna sit. So this is gonna be you sitting at this spot. And you're gonna make a little pile on the floor of your craft sticks. So you've got different colors of craft sticks. There's long ones and short ones. There's 8 different colors, I think, or 6 different colors. I think it's 8. Different colors, and then each color has 2 sizes. So each one of those is a different species. So you've got long green and short green and long red and short red. And so that's your species pool. So you're sitting here, you're over here, you're on the mainland. And you're going to throw your species one at a time, your craft sticks one at a time from your pile. And you want to do it in a pile so that you can just randomly grab any one. And you're going to throw them, and there's a set amount of time. It says in your lab book. I should have grabbed a lab book. I didn't. Oh, I do have one. Let me just grab the lab book because I don't want to steer you wrong here. Just give me 1 second. Hang on. Sorry about that. Okay, so the lab book says, oh, it's not amount of time. It's telling you how many sticks to throw. Good thing I looked that up. It says throw 20 sticks. So throw them one at a time. And so when you're throwing your sticks, some of them are going to land on the island. Some of them will land in the ocean. You've got your different colors of sticks. Some are barely on. I'm not going to do all of them. So after you've thrown your 20 sticks, you're going to get up and you're going to go over to your island, and anything that ended up in the ocean or anything that is not 50% on the island is dead. So you're just going to take the dead ones. So this green one, that one, and I guess this red one's not quite on. And I would just take those sticks and just put them back into your little pile. So they're back in your species pool so you don't run out of sticks. And the other thing you take out is where one species landed on top of another one. So we can see a spot uh, right here where a red one landed on top of a green one. So the green one's been out competed or eaten or something like that. So the green one's going to be taken away as well and put back into the pile. So once you've taken out the dead things, so the things that didn't get on your island, that guy's dead too. Things that didn't climb up onto the island and things that got landed on top of, then you just count how many species you have in your island. And you've got a little data table where you're just going to tally. You're just going to put a tick mark. So I can see I have a long blue species. So I'll put a little tick mark for long blue. I've got short blue. I've got long red. I've got short red. And I've got long green. And it doesn't, you don't have to keep track that I have like 4 long reds and 3 short reds. You just have to count species, not individuals. So it's just, it doesn't matter how many of each you have. You're just going to count the number of species that you have. And then, so that's the end of round 1. Then round 2, you're going to once again throw 20 of your sticks one at a time. And so some of them will land on top of each other. Some will land in the ocean. You go through exactly the same thing. And once again, once you've done your 20, you go and take off the things that didn't quite make it on the island, that land in the ocean, take off things that were outcompeted, so the things that have something else on top of them. And so now you'll see you've got more species now. And then you go ahead and you just tally what species you have. So I have the long greens and the short greens and the long reds and the short reds and which species are there. So it doesn't matter how many of each. And you're going to do 15 rounds of this. So you're going to, so we're going to have 15 rounds. And each time you're throwing 20 sticks. Then you remove the dead ones. And then you just note what species you have. So by the end, by the 15 rounds, you basically are going to get to your equilibrium number of species for that size of an island. Once you've done your 15 rounds for that island, then you're going to go ahead and move over. Take your legs with you. Go ahead and move over to the next one. Oh, I'm still an eraser. Here we go. To the next island and do the same thing. So, or you can just pick the tape up, collect up all your sticks and use the same area. Don't try to do 3 nested. You don't want to like do an island in an island in an island, because then you can't remove the ones that are partway off. And your results will be dependent of each other on each other as opposed to independent. So you really, that's something that you don't want to do. So you want to do them as 3 separate islands. So when you think about as you're doing this, then you'll sort of get an idea as how we'll be using this data to graph our immigration and extinction. Because if we have our graph here, you will see for one particular island, you'll see that when you start with very few species, so this is my number of species and this is my rate of immigration, that when I have very few species, all the species are new ones. And when you get to the end of the 15 rounds, if it's a big island, you might have all your species and you might go down to 0 new ones coming on there. And then you'll also be able to measure how many species disappeared from one round to a next. And so you don't get a lot of extinction happening at the beginning, but then as you get more sticks on there, you can imagine you get higher rates of extinction, and you will be able to calculate the equilibrium number of species for each island. Over the class, we have several sizes of islands, so we will be able eventually to pool that data, and we will be able to look at the species area relationship. So we'll have area and number of species, and we'll have, several people who have done small islands, medium islands, large islands, and we'll be able to see if we get a species area curve like that. So, so that's where you're headed in this lab, are those 2 graphs. So the 2 graphs, it's complicated to do the 2 graphs, and these will be part of your analysis the following week. So we'll talk more about that. So those will be the analysis part. What you're doing this week is getting the data. So I'm going to stop sharing the whiteboard and I'm going to share my screen. You guys still with me? Oh, I've got more people now. Good. All right. Can you see my screen? It says Island Biogeography now. So when we're in the Island Biogeography, you click the link in the week, in the week's instructions. It has a link to the video. Watch the video. It goes over everything I've just been talking about. So some of the theory behind it, talks about how the model actually works briefly, and then goes step by step on what you're doing, and shows me doing it outside, but you can always do it inside. That's a stray cat that lives under our house. That's Lemieux. She was enjoying this a lot. And then so this is your data sheet in your lab book. So you're going to be just putting little tallies or check marks across here. You don't have to count how many of each species you have. Once you've done your 3 islands, you're going to submit that data in the form that's linked in your Blackboard site. And so you just put in your name, the campus you're enrolled in, and then what island size you picked. So you've got the choices of the island sizes. And then this is just basically, it's exactly the same as the table you have in your book. So let's say I had red long, and I can have red short, and I can scroll over. Here we go. Scroll over because I had blue short and blue long. So for each round, you're just going to enter this data into the table. And then take the last 5 years from your data and just see how many species you had on average for the last 5 years and put that number in there. And then if you had anything that you wanted to comment on or something that went wrong, some people have their cats steal their sticks, some people have their dogs steal their sticks. So you can put any comments in here. And then when you've submitted that, then you do it for your second island and submit it for your third island as well. So you're going to, these are the instructions I've just told you, just making sure I haven't forgotten anything. So then you're going to submit the form and then update your blog and do the little assignment right here, Island Biogeography data collection, where you provide a link to your blog, and the pictures are going to be on your blog. And did you put your data on the form, and how long did it take you to do it? So this is fairly easy. It's kind of fun. You get to throw things. I also included here, this is a lecture on geographic ecology and species area curves, which gives you the background on that. Starts a little bit talking about Alexander von Humboldt, and then gets into, which is the area of geographic ecology, and then it gets into the species area curve, if you want to fast forward a little bit. And then this is the one outlining the theory of island biogeography that we're actually going to be testing with our data. And so that is it for this coming week's lab. So I think I've covered everything. Yes. So do you have any questions? You will when you're doing it. Just don't hesitate to drop me a line. But that's exactly what I would do on the board in the classroom before we would do it in the classroom. And instead of the craft sticks, we had different colored, well, we had different little plastic frogs that we had to write numbers on all of them. It was way fun to have the little frogs. I just didn't think you guys wanted to sit and write numbers on all your frogs because it was really tedious. So that's why I found the different sizes of craft sticks to do this, because the different colors and sizes just saved you writing the species number on all of the little frogs. But you can imagine it's whatever animals you want it to be. So you think you can handle this? I think you can. I'm going to stop recording.